So today I will talk about line, surface and volume element in terms of spherical polar coordinates. So first of all, let me write down a small Python script so that it may help us in the visualization. So I have written a small Python script here. I will upload it on my web page. Yeah, this is the Python script which I have written. It's a small script. And I will share it on my web page arunphy.org to show the small volume element in spherical polar coordinate system. So let me run it first of all. So I will using Python 3 as a compiler and 8.py. I am using a Linux environment. Say this is a small Python script which I have written and it shows the small volume element. So this is the small volume element. Let me mark this as first of all ABCD. So here, so this point is A. So this is A point. Say this is B. This is C and this is T. Similarly, this point is A prime. This point is B prime, and say this point is C prime, and say this is the D prime. So this is the small volume element. So it is covered with it is A, B, C, D, D prime, A prime, B prime, and C prime. So this is a very small volume element. And here these are the different faces. Say one face is this one, and another face is let me draw with another color. Yeah, this is another face, this is another face, and the third one face is represented by say black color. So this is the third face, and there are three other faces parallel to these faces. So I will talk about only these three faces and try to find out their surface area. And I will also try to find out the line element. So what is the line element? Let us have a look at that. So let me clear the screen now. So this is a small element. Say, yeah. So this is a small element. Say the coordinates which I have shown, this is r theta phi, and say this is a small line element. This is drawn by this line. Let me change the color. Yeah. So this is that line. This is a point. Say this point is P and say this point is Q. So the coordinates of P point are r, theta and phi, and the coordinates of Q point are r plus dr and theta plus d theta and phi plus d phi. So how this line element can be written? So let us try to look at that. So it is r dr. So this dr vector is the dr vector, and this consists of three mutually perpendicular vectors. So one length is this is the dr. So this length is basically dr vector, and it is along r cap, and say this is phi, so it is along phi vector. So this distance is basically r sine theta. I will talk about it later on. R sine theta, d phi and the d cap, and say this is along theta cap. So it is r d theta cap. So this consists of three unit vectors. So one unit vector is along r cap, and another is along theta cap, and another is along phi cap. So it is basically drr vector plus it is r d theta d cap, and it is r sine theta d phi phi cap. So this is a way that how the line element can be written as, right? So now I will talk about how this r sine theta d theta will comes out to be along this side, and r d theta will comes out to be this length basically. I will talk about it right now when I will talk about that is area elements. So let us go to that now. So here I will talk about basically line element, and line element is basically written as this, yeah. So dr vector, it can be written as drr cap plus r d theta theta cap and r sine theta d phi and the phi cap. So this is the line element, and we can write down its magnitude is like this. So it is equal to dr square plus r square d theta square plus r square sine square theta and d phi square. So this is a way that how this small line element can be written in terms of spherical polar coordinates. So let us have a look at that is yeah, this is the situation. As we know that this, when I talk about this spherical polar coordinates and say it is a r and say it is x-axis and it is y-axis and say it is z-axis, then this is the radial vector. So it is making an angle theta with the z-axis, and when r changes then theta changes like this. So that's what I have shown here. So it is theta and it is a d theta, because here the coordinates are r theta plus d theta comma phi. So that means this is a small incremental change in theta. So let us represent this angle by theta. Now as we know that this distance is r, up to here this distance is r, and it is changing radially like this. So r will remains the same for this. It's like a curve. Means the situation is like this. It is this type of situation. This distance is r, this distance is r, and say this is d theta, and say this is the length of the arc, and let us represent this length of the arc as because we know that theta is equal to L upon r. So which implies this length is this small length which is represented by this red color. So it is basically theta into r. But here in our case, what is theta? Theta is d theta. Theta is d theta, and r will remain as it is. So that's why I am writing this particular distance as r d theta. This distance is r d theta. And let us try to look at the another part. Say it is x-axis, it is y-axis, and z-axis is this one. Either I call it as also a z-axis. So that means when I draw a perpendicular from this r theta phi, this point to here on xy plane, I am drawing a perpendicular over the xy plane because this is xy plane. So when I am drawing this xy plane, then this is making an angle phi with the x-axis. And when I move from one point to the another point, then if I draw a perpendicular from this point to this point, then it will become a d phi. This will become d phi, right? When I look at in this manner, means phi is changing. So as we know that earlier, that this particular distance is known as r sine theta, as we have talked about in the earlier lectures, because as say this is the situation. If I draw a perpendicular over this and this angle is phi, and say this angle is theta, then this angle is also theta and it is perpendicular, then this distance is known as r sine theta. I talked about it in earlier lectures so many times, so I use that concept here. So this distance is r sine theta, and similarly it's like a curve. So that means this also remains the same distance, but this is angle d phi. So again, using the concept of theta is equal to L upon r, but here in place of theta we are having d phi, and in place of L is this length which is represented by red curve here, and r is basically r sine theta, which is basically this distance, the radial distance. So using this I can calculate this length. So this length comes out to be r sine theta d phi. That's what we are getting here, right? So these are the few things which we have to remember. Now let us go further. Yeah, now this area, now I marked this is A, B, this is C and D. So this area which is marked here with the red color, this shaded portion, is basically this consists of two vectors. So one vector is a r d theta and it is along this direction and it is theta cap. So this AB vector is represented by r d theta, theta cap, and similarly AD vector is represented by this one, means r sine theta d phi and the phi cap. So I just put their values. So it is r square sine theta d theta and d phi, and this is the cross product of these two vectors. So that means this is r square sine theta d phi, and it will become r cap because r cross theta is basically phi cap and theta cross phi is basically r cap, and phi cross r is basically theta cap, because these all are mutually perpendicular vectors. So I use that concept. So that means this area element is basically along r cap. So that means this area ABCD is along r cap, right? So this is the one part which I have derived, and so let us call it as the area element along r cap. Now let us go to the another area elements. So similarly, say here it is r theta phi and it is r theta phi and the d phi. So that means phi is changing along this way. I've just oriented it in this way. So it is r sine theta, as we know that, and r is changing along this direction because it is r theta phi and it is r d r theta and phi. So this is the direction of r cap and this is the direction of this one. So this area A prime, D prime and D is basically AD cross AD vector cross AA prime vector. So and these are their values which I have substituted. So as we know that phi cross r is equal to theta cap. So therefore it is written as r sine theta dr d phi and theta cap. So it can be written as small area element in terms of in the direction of theta cap. And similarly we can go to the next part of it, that is it's there. Again I have oriented it in this way, and if I try to look at it, so AB is basically along this theta cap and this is along r cap, as I discussed in the earlier lecture, and this distance is dr r cap and this distance is r d theta cap. So if I put their values here, because it is basically represented by A prime cross A prime cross it is AB cross. If I put their values here, so this can be written like this. So it is r dr d theta and the phi cap, as been discussed here, that r and theta, r cap cross theta cap is basically phi cap. So that means this can be written as area element along the phi cap direction. So thus we have derived various small area elements along different directions. So now let us try to find out the volume element. So these all the 6 faces, I try to find out the area element for the 3 faces, and the area corresponding to other 3 faces parallel to these, that will remains the same. So now I will talk about volume element, small volume element, and that is represented by dV. So what is dB? So if I again go back to here, so let me make it clear. Yeah, so it is, let me little bit rotate it. Yeah, so that will be better. So say this direction is basically, so this direction is r cap, and say this direction is phi cap, and say this direction is theta cap. So these 3 vectors will constitute a small volume element, and as we know that one vector is a dr r cap, this one, so this is basically represented by dr r cap, and this particular part is represented by r d theta, theta cap, and here this part is basically represented by, as I have discussed earlier, so it is r sine theta d phi and the phi cap. So this small volume element consists of 3 mutually perpendicular vectors. So one, say it is a B, C, D, it is A prime, B prime, C prime and the D prime. So it consists of 3 mutually perpendicular vectors. So one vector is a AA prime vector, and another is AB vector, and the third one is the AD vector. So that means volume element is basically the scalar triple product. It is the scalar triple product. So that means that scalar product, triple product, is basically is the small volume element, because I am considering a small region. So it is AA prime vector dot AB cross AD. So this basically used to find out the volume of this one. So let me take it screenshot first of all. Yeah, let's just take it. Just a minute. Yeah. So that means, let me put their values here. So if I put their values, so it will become d r r cap and r d theta, theta cap cross r sine theta d phi phi cap, and let me do little algebra now. So it will become d r r cap, sorry, and here it is r square sine theta, it's both put together, r square sine theta d theta and d phi, and the theta cross phi, and theta cross phi is nothing but it is equal to r cap. So it can be written as dr r cap and r square sine theta d theta d phi and r cap, and this is r cap, this is r cap, so their dot product will always unity. So it can be written as r square sine theta dr d theta and d phi. So thus small volume can be written as like this. So So dB, it is equal to r square sine theta dr d theta and d phi, and this is a scalar quantity. So as today I have shown you that how this small line element, volume element and surface element can be represented in terms of spherical polar coordinates, and I have also tried to visualize all these things with the help of a this Python script, and I am going to share it on www.arunphy.org. On this web page I upload this also. So thanks for watching this lecture, and in the next lecture I will talk about this what we call a plane angle and the solid angle.